All right, we've got on number 17 a classic law of conservation of momentum with a classic area for you to bugger it up. So please, even if you haven't been doing it before, I want you, if you haven't tried this problem yet, pause the video, go try it, and then come back. Okay, I'll wait. Go pause it now. Okay, welcome back. Okay, I hope you got that the answer is 6. If you didn't get 6, pay extra close attention. Don't erase your stuff. Make corrections to it, and then do this problem again, starting fresh from the beginning. That's the way that you will learn more than anyone else today, because you got it wrong first. Okay, you're gonna learn more than anyone. We're all jealous. Okay, let me test my pen. Yes. Okay, so we have a block, another block, and they're moving, right? And then one of them slows down, and the other one, we don't know what it does. We could logic it through maybe, but I'm just gonna math my way out because I'm better at math. Okay, so we know the momentum before has to equal the momentum after. Before I do this little 0 symbol, it's pronounced not. N-A-U-G-H-T. F for final. The P stands for momentum. I don't know why. I guess if M, we can't use M because we use that for mass and meters. So P, in my class I call it momentum. So, momentum. That means momentum. All right, so we got the momentum of A plus the momentum of B equals the final momentum of A plus the final momentum of B. So if one of them was still and the other one had a lot of momentum and like hits it, then they have less velocity but the same total momentum, right? You can't change the total momentum. Okay, so let's look at what this means for us. So we have MA VA plus that's an A. MVVB equals MAVA A. I cannot talk at the same time. Plus MBVB. Okay, what's really happening is I can hear my parents downstairs. They just got home, so probably they're going to be hollering my name up the stairs. I'm 30 years old. I bet it happens. Wait. Okay. Mass of A is 4. Velocity of A is 9. Mass of B is 2. Velocity of B, and if you missed it, it was probably right here, -8. Okay. If you put the velocity of this one as positive, you have to make this one negative. You could have made the 8 positive and the 9 negative. It does not matter. Generally, I do like going to the right is positive and going to the left is negative. But sometimes I don't. Sometimes I do it the other way just to avoid a negative number. You know, in algebra, sometimes like you divide first, and sometimes you have options on steps. Like there's a few where like you have to do them in that order, but sometimes you have like freedom. This is one of those, I'm sure maybe your teacher does it one way and your TA does it another, and I might do it a third. Like as long as you are internally consistent within the problem, it doesn't matter. We're not like changing all of physics. It's a personal preference. Okay, so I made 9 to the right. I made that positive. That means this 8 we have to make negative, because velocity is speed and direction. So you have to put that they are different directions. Okay, you have to. Okay, the mass doesn't change just because they collide. Sometimes in these collisions they become one like mega block system, and you just add the masses up. But they didn't this time. This is what we call, was it elastic or it's an elastic collision. They bounced off. Is it perfectly elastic? Did it say? It doesn't say. We'll assume it was perfectly elastic. Okay, mass of A is still 4. Velocity of A, now it's only 2. Is it -2? Well, it's the same direction as the 9. So whatever you put for the 9, you put the same sign for the 2. The velocity of B is... Nope, we don't know, but the mass is 2. And the velocity is what we're solving for. So one equation, one unknown, we can do this. So 9 times 4 is 36. -8 times 2 is -16. 4 times 2 is 8 plus 2v. 36 minus 16 is 20 equals 8 plus 2v. This is like cute little algebra. I like this. 12 equals 2v. Divide both sides by 2, so 6 meters per second. That's our velocity. That's a positive number, which means it's going to the right. It's going the same direction as all the other positive numbers. Okay, so it was going fast and slow, and then that was their collision. Okay, I'm so bummed that y'all are taking this for the first time like at home, so you can't do the cool lab where you just get cars and just like smash them into each other for like an hour. It sounds, well, actually it sounds awesome, but it's even more awesome than it sounds. All right, so you can look up some videos on YouTube. It's a good time. Collision carts. All right, next one.